Okay, welcome to video number 2. Today we're going to first talk about how to make a box plot. So we have our 5-number summary comprised of our minimum, our quarter 1, our median, our quarter 3, and our maximum. So here's what you do. First we have a central box is drawn from the first quartile to the third quartile. So we're actually drawing a rectangle. Then we make a line somewhere in the box, not necessarily directly in the middle, to mark where the median is. And then from the edges of the box, we make our whiskers out to the minimum value and the maximum value. And note that these are, we do this for any observations that are not outliers. Outliers are marked with an asterisk. So here's our data again. And here's our timeline at the bottom, or our travel timeline at the bottom. Here are our 5 numbers. And so here's our box. Notice Q1 on the left at 15, Q3 on the right at 42.5, the median at 22.5, which is not in the middle, it's on the left side. And then our minimum is 5. Our maximum, recall that 85 is an outlier, so the line on the right only goes to 65, and then we put an asterisk, or in this case they put a different symbol, at 85. Okay, there we go. Box and whisker chart, box plot, in a nutshell. We will practice this a little bit. Okay, common mistakes. Don't do these things. Students sometimes refer to the IQR, the interquartile range, as the box. The interquartile range is a number. Students will sometimes describe a symmetrical box plot as approximately normal, which we're going to get into the normal distribution in the next unit. Normal distribution is not the same. Even if a box plot is symmetrical, we don't know anything about the data values in the box, so we cannot say that it is normal. Okay, also, when describing data, some common words or good words to use so far would be things like a bit more, quite a bit more, a little less than, more variable, less variable, things like that. Okay, now we move on. Standard deviation. I hope that everybody has some idea of standard deviation. Standard deviation is the most common measure of spread and how it looks, how spread looks from each observation. Let me say this again. The most common measure of spread looks at how far each observation is from the mean. It's called a standard deviation. Consider the following data on the number of pets owned by a group of children. So we have our dot plot here. With this data, we can calculate the mean and each deviation. Okay, the deviation is the difference between the observation and the mean. So the observation minus the mean. In this case, the mean is 5. So for the data value of 1, the deviation is 1 minus 5, or negative 4. For the data value of 8, the deviation is 8 minus 5, or 3. So we do this for every observation. We calculate the data value minus the mean, and we get these numbers like in this chart. Okay? Now we could add them up. If we add them up, what do you think we would get? Actually, what we end up getting is 0, because we have negative numbers and positive numbers. They all add up to 0. So how do we deal with that? What we do is we're going to square each one, and then we're going to average the squared numbers, and we're going to divide that. We're going to average it, almost average it. We're going to square them, add them up, and then divide by n minus 1. And for right now, we're not going to talk about why it's n minus 1 rather than n. It has something to do with the n minus 1 giving us a slightly better value. This is called the variance. And then we're going to take the square root of the variance, and this is called the standard deviation. So in a nutshell, here we go. We have our xi minus the mean, and then we have that number squared, and then we're going to add that up. And then we're going to take the square root, and we end up with 6.5. I'm sorry, I take that back. The average squared deviation is the sum divided by 9 minus 1, or 8, gives us 6.5. The square root of the variance is the standard deviation, and that is approximately 2.55. standard deviation measures the average distance of the observations from their mean, okay? And the square of the standard deviation is called the variance. So here's some formulas. This looks pretty scary. Just take a look at it and see if you can figure out what's here. It's really not anywhere near as bad as it looks. And there's our standard deviation. So we now have a choice. We can either look at the mean and the standard deviation, or the median and the interquartile range for describing center and spread. So when do we want to use each one? We want to use the median and the interquartile range when the mean and the standard deviation are, the median and IQR are usually better when the data is skewed. When the data is symmetrical or roughly symmetrical, then we can use the mean and the standard deviation. Also outliers, we want to avoid outliers when we're talking about mean and standard deviation, because remember how the outlier pulls the mean away from the middle. Also, numerical summaries do not fully describe the shape of a distribution. Always make a graph. Always, always. Okay, so here's a 4-step process you can follow for analyzing a statistical problem. Step 1, what is the question? Step 2, make a plan. Step 3, make graphs, carry out your calculations. Step 4, write your conclusion. Your conclusion should always be in sentences, and they should always be complete thoughts. And here's a summary of what we learned, which matches what we said we were going to learn in this unit.